Okay, so now we're looking at this paper, okay? This is the one that I first handed you, okay? So it has a little triangle in the top of it and a little drawing right here. So that's the one that we're working on right now. This is going to be where we're going to be writing down some of the notes, okay? All right. Our goal is to get through these, so you're going to kind of see me move through these fairly quickly, and then that way you have the rest of the time to do your practice, okay? And you won't have to do anything at home. All right, so what we've got, this little image right here, it got cut off, my apologies. Just go ahead and make that a little circle and a little arrow that was going into a cup. All right, so what we see there in that little image right there, okay, is that kind of like the Gatorade analogy, okay? The whole idea of, if you open it, Trey, if you open it and then close it, it'll do it. Never mind. Okay. All right, so we have a solute. That was the Gatorade mix or the Kool-Aid mix. We put it into water. The water is your solvent. Solvent. Okay, so we put solute into a solvent. Together, this makes a solution. A solution. All right, those are all vocabulary words. And so you guys, on the notes page that we were just working on with the warm-up, I don't care. I would probably put this one towards the warm-up page front up because we're going to keep using it. And then I would put this one next. And then put those other two or in the back because those are homeworks. Sorry. And if you still have your lab paper, that means you had 5 papers. You need to turn it in. Oh, she needed. They need it. Okay. All right, we're all good? Whew. Okay. So, once again, solute, solvent, solution. Those were all definitions, okay? So you can add these in as we go through notes throughout this chapter. Okay, you can kind of put in your own definitions for these, all right, until the day when we're doing the review. So, solute goes into solvent, solution. We're going to now see that we're going to talk about the concentration of a solution. And what that is, like I said, you already know. If you have more sugar in your juice, it tastes sweeter. That's more concentrated, right? So that's a ratio of solute to solvent. You have more of this, less of this, higher concentration. If you water it down, you have more solvent, less solute. That's diluted. That's a lower number, okay? So that's going to be kind of what we're working with number-wise. All right, so read along with me as I'm kind of looking at this top sentence. It says, molarity is a way of describing concentration of solutions. So there's vocabulary words like crazy in here, right? So molarity, concentration, solutions. We can say that something is dilute or concentrated, just like we did in our warm-up. Okay, but those are not very definite terms. They're very relative terms, meaning you determine if you think it's dilute or not, right? Okay, so the math part of this is what's going to take that away. It's going to now be defined. So we're going to use molarity. It's the number of moles, so circle the word moles, of solute in 1 liter of solution. Molarity is the number of moles in 1 liter of solution. Please make sure you have those 2 words circled because that's going to be the part that makes it difficult. The rest of this equation, super easy, just division, okay? But the fact that we have to be in moles and we have to be in liters is what's going to cause us some issues every once in a while. All right, the symbol for molarity is this capital M. So if you remember when you did this lab on Monday, as well as previous labs, you've seen bottles that have, like, the ones on Monday said 0.05 M. And some of you guys were wondering what that M was. Now we know. It's going to be concentration. So 0.05 is pretty dilute. It's pretty watered down. Sorry, you could have put it right there. Yeah, you're good. All right. So, moving on. we are now going to look at our equation. So the equation for molarity is equal to moles divided by liters, right? These are your different units and variables that we're looking at, okay? Up here, I have a triangle ready to go for you, okay? So some of us kind of struggle with plugging in for different things because this right here looks easy. Like you're like, okay, I just divide the two. And you're like, yeah, of course. But what if I'm solving for liters? Do you know how to do the algebra? What if I'm solving for moles? Do you know how to do that algebra? So this triangle is supposed to help alleviate some of that angst right there, okay? So this triangle up here is what we got when we had density formulas, okay? So what you do with the triangle, you cover up the letter that you're solving for. So we've used the triangle, but a lot of us forgot it. So you cover up what you're solving for. So for example, if I'm solving for molarity, I would cover up the M. This tells me moles divided by liters. If I was solving for moles, I would cover up the word moles. Molarity times liters. If I'm solving for liters, volume, I'm going to say moles divided by molarity. Okay? Easy enough? So you have this to use. Please use it. Don't guess. All right? Okay. So now let's look at how to calculate. So it says to, actually, really quick, add this to your notes. Say moles of solute, because it's the ratio specifically of solute to solvent. So we're going to say moles of solute over liters of solvent, so divided by, and that gives me the molarity of the solution. So once again, it's a ratio of solute to solvent to give me the concentration. That's what we're looking at. Easy stuff, I promise. Just think back to Gatorade, all that stuff that we were just talking about. All right, so now we're looking at the steps. It says how to calculate molarity of a solution. It says convert to grams of solute to what? Miss Vogel, there is no grams. Absolutely. You're absolutely correct. Which is why every once in a while, for example, the first one on the homework, you're going to have to convert. That takes us back a couple chapters. All right? It's not as bad as what stoichiometry was for a lot of us, but it was the first one where we first did times in a line. Okay? So what I need you to add to your little triangle, just so when you're doing this on your own, you'll know, okay, if I'm in grams and I need to get it to moles, or in my answer, if I get moles and I need it to convert it to grams, you might have to switch between those two. But these guys are sort of interchangeable. You just got to be doing the conversion. Which leads me to, look down your paper right here. I gave you both of your setups, okay? So if you're trying to go from grams to moles, which is what we're doing in this first problem, you're going to start with your given in grams. You're going to be multiplying it by 1 over the molar mass, or you're dividing it by the molar mass. You guys remember that chapter? It was easy. It wasn't as bad as the going all the way across the railroad tracks, right? But you had to think, okay, if it's diagonal, I'm dividing. If it's next to it, I'm multiplying. You guys kind of remember that a little bit? Okay, so if you want to cross out that 1, you can. If at the end you have to convert it back to grams, like let's just say you solve for moles and you have to convert to grams, you'll have whatever you calculated with moles. You'll have 1 mole on the bottom. The molar mass will be on the top. How do we find molar mass again? Using the what? Periodic table. Okay, good. All right. So that's the worst it'll get, is you have to add that step in there, okay? Everything else, super simple, so don't overthink it. All right, the other thing, just so I don't run out of time, we'll come back to this in a minute, but the conversion of milliliters to liters. In our labs, everything has been measured in milliliters. Rarely do we ever pull out a liter graduated cylinder, because that's huge. Like, you guys use the ones that fit in the cabinets. They're little itty-bitty graduated cylinders. They're easy. They're smaller. So we usually measure things in milliliters, not liters. So you have to be able to convert it. So your conversion is that there are 1,000 milliliters in 1 liter. So go ahead and add that to this part right here. There are 1,000 milliliters in 1 liter. Which means when you're given a number in milliliters, you can't leave it in milliliters because the problem needs it, or the equation needs it to be in liters. That's the definition of molarity. So in order to convert it back, we're going to move that decimal 3 to the left. So if I have my decimal here, I would go 3 to the left. So it would be 0.001 liters. Okay, so just write those two conversions. That way you have them ready to go. All right. Are we all good so far? Okay, let's walk through a couple of these problems. We'll kind of refer to those two things. Honestly, that is the most difficult it gets. Okay? All right. So, for example, one is that if I have 3.5 liters of solution, so we're going to still continue to do that underlining and circling thing. 3.5 liters of solution contains 90 grams of sodium chloride. What is the molarity? We're going to circle what we're solving for. So, we realize that we have grams, so that tells me I have to do something with that. So, this first step, we see that we put the 90 up here. I divided it by the molar mass down here in order to get 1.54 moles. Okay, so we did 90 divided by 58.44. Once we had that moles, that's the part that went in to our actual calculation. So we have 1.54 divided by 3.5, straight from the problem. When we type that into our calculator, simple division, this is the answer we would get. Okay, so that's example 1. Example 2 kind of goes in the same route, so let's go ahead and work through that. It says, what is the molarity of a 2-liter solution that contains 10 grams of sodium chloride? 2-liter solution, 10 grams of sodium chloride. So once again, we see that grams, and we're like, oh man, we got to do that extra step. That we can't use. This one's okay. All right, so we're going to go ahead and take care of our grams. We're going to convert using this step over here. Okay, so I'm going to go ahead and say 10 grams. I'm going to do times in a line. I know that that's over 1. I'm bringing my words down to the right. Looking here, it says given grams, 1 over the molar mass. So 1 mole, okay, over the molar mass. So the molar mass of sodium chloride means that I'm going to look at a periodic table. I'm going to add together a sodium plus a chlorine. They did already give us that answer, though, in the previous problem. So 58.44 molar mass. So if you have your calculator, you can practice typing these in. You would be doing 10 divided by 58.44 since it's diagonal from it. 10 divided by 58.44. So when you do that, you should be ending up with the answer 0.17 exactly, 0.17 moles. All right, so we got our first step. We know what we are in moles. Okay, so now we're ready to actually plug into the formula, which this will probably be the step that we start you at. Okay, so if that helps maybe relieve a little bit of anxiety on this, we most likely will be giving you those more. Okay, so you put moles, we're solving for, what is the molarity? I didn't even circle it, am I bad? All right, so we're solving for molarity. So looking at our triangle, we're solving for big M, moles divided by liters. So I'm going to go ahead and say big M is equal to moles over liters. So then when I go plug that in, I have 0.17 divided by 2.0. When I plug that one in, divide it, I get 0.085 molarity. And that is our final answer. Okay, so not too bad. Just division. All right, so like I said, that's the worst that it'll get right there, that problem. Okay, hopefully it felt easy, right? I would say the other thing that could possibly be harder is if I had given you like 2 milliliters and asked you to make sure you convert that. But don't worry about that right now. All right, number 3, example 3. How many moles of NaCl, so that's what we're solving for, I'm going to circle that word, moles, are in 5-liter solution that is 4 molar? Okay, a molar solution, 4 molar solution. So I'm solving for moles. So I'm going to go ahead and look at my triangle up here. I'm going to cover up the word moles. That tells me I'm doing molarity times liters, or molarity times volume. So I'm going to go ahead and write that out. Moles is equal to molarity times volume. And then I'm going to go ahead and solve for it. So moles is equal to, molarity of 4 times 5.0. So what is 4 times 5? It's 4 times 5. You guys should know this. It's 20. Yep, 20. 20. You guys are good. No worries. All right, so we have 20.0 moles. Good. And if you didn't, good news, you get to use a calculator, right? That'll be fine. You guys are great. All right. The next question. Okay, so you see that was a lot simpler. We didn't have to do extra steps. Not bad. All right, example 4. What is the volume, so I'm going to circle the word volume, of a 3 molar solution that contains 0.5 moles of NaCl? So I would say the other thing that's difficult is making sure you can pull these, right? So you got to be ready to say that, you know, that's moles, you know that that's the big M, and this one is liters if we're solving for volume, right? So make sure you're ready to interpret your questions correctly. So we're solving now for liters, or the volume. So we are going to cover up where it says liters volume. I have moles divided by molarity. I'm going to go ahead and write that out. So liters is equal to moles divided by molarity. So I'm going to go ahead and fill in 0.5 moles divided by 3. So when you type that in, 0.5 divided by 3, you will get 0.17 liters. So, follow-up question, how many milliliters is that? It's not going to be 17, but you're going the right direction. Unless somebody said something else and I misheard you. Not 7 either, no. So when you said 17, you were heading in the right direction with that decimal. 170 is absolutely correct. So basically, if we have to move it to the left in order to go to liters, if we're going backwards, we're going to move it to the right. Okay, so we're going to make it a bigger number. So we would have 170 milliliters. Okay, so that's that conversion thing. Just be ready for it eventually. All right, it doesn't happen on all the problems again. How do we get to 170? Oh, we started with 0.17, and I moved that decimal 1, 2, 3 to the right.
Why is it moving this?
Because 1,000 milliliters is equal to 1 liter. So you technically took it and you multiplied this by 1,000. You're multiplying it by 1,000. Does that make sense? No, that's why I'm only doing it on that example. You're good. All right, so it's good old metric system. We're the only ones in the world who don't use the metric system. All right, so let me get you guys through example 5 real quick. Example 5 says how many grams of NaCl? So circle the word grams, but give yourself a little reminder that means that what are we solving for? If we're being asked for grams, we're solving for moles, exactly. So up here we put grams, and we connect it to the word moles. So we will be solving for moles in order to make a 0.5 molar solution with 1.5 liters of that solvent. So we are going to solve for moles. So looking at our setup, we're going to cover up the word mole. We have molarity times liters. So I'm going to have moles is equal to molarity times liters. I'm going to bring those numbers down from my problem. So I have 0.5 times 1.5. So when I multiply those together, I will get 0.75 moles. Okay? 0.75 moles. But the question isn't asking for moles, it's asking for grams. So this is where you're going to use the little bit that Ms. Fogel wrote in on your notes and you guys filled in just a second ago. So look up at the top on the conversion. we need to go moles to grams on this answer. Okay? So I'm just going to kind of wing it up here. We're going to put what we calculated for moles. We're going to multiply it by the molar mass. What we calculated times the molar mass. So I'll go ahead and put 0.75 is over 1 times in a line. We have 1 mole at the bottom. And the molar mass of sodium chloride, which is still the same, so 58.44 grams. So you're multiplying those. Your final answer will be 43.83. Okay? 43.83 grams. All right? So that right there, again, is as hard as it'll get. Okay? So you think you can handle this? At least using the triangle a little bit? Okay. Pull out the paper, or turn to the paper that you guys got while the other one that I handed you. You want to be on the side that says Molarity Calculations. Molarity Calculations. Okay. With Molarity Calculations, it might be helpful to put this part at the top just so you have the triangle so you don't have to sit there and flip back and forth. Might be helpful to put that there, okay? Moles, give the connection to grams. The only one that deals with grams is the first one. So you want to get the molar mass of hydrochloric acid, or HCl. You're going to add together a hydrogen and a chlorine. Okay, that is the only one that does that. 2, 3, and 4 you can knock out in literally 5 minutes, as long as you're using your triangle. Okay, just remind yourself this is volume, and I think that's all that I would put there. So your homework tonight is to do 1 through 4. Do your best on number 1, so maybe don't start with that one. Knock out 2, 3, and 4, so at least those are done, and then you can come back to number 1 after. Now, I put the answers up on the board in no particular order, and I will just go ahead and put these numbers at the top of this page, so you're more than welcome to either take a picture before you leave or write them down. 0.615, 4.67, 1.23, and I will say one of them is the moles for this one, okay? So one of them is also moles. 20.15 and 0.54. So if you notice, there's 5 numbers, only 4 questions, so 5 of those numbers will show up. So as long as you're getting one of those numbers, that's a good sign. Okay? All right. Good job. Nice work. Let me know if you have any questions. The rest of the time is for you. Kind of like 3, 2, 1. I'm sorry. Sorry. There you go. Oh, that's blurry. You're good. Yeah. That's why I was hurrying. I was like, sorry.